All right, kudos to you for being here and trying to get a little bit of extra work done. Continue practice is the main way to make sure that you're doing a good job on this. So I'm going to run through, we'll see if I get through all these in one video or not. So our first one, it says, what's the possible molar ratios? Again, all that you're looking for in the molar ratios are the numbers in front of our substances in the balanced formula. When we put numbers in front, we're effectively saying how many of each substance are going to be required to react with one another and how many units of each substance would be produced. So the way that this one is written, I mean, it literally tells us that I need one of these to react with 8 of those. They produce 5 of these. They produce 6 of those. So the molar ratios for the C5H12 are simply, it's going to be one of them, and we'll make a little 2 dots there for a ratio sign. For each one of them, it would be 1 to 8 if I were talking about oxygen. It would be 1 to 5 if we were doing carbon dioxide, and it would be 1 to 6 if we were looking at the water. Again, that's all that we really need to do. The only semi-tricky part of this sometimes is we can reduce them. If you were asked to do the molar ratios between oxygen and water, for example, you might write down 8 oxygens to 6 waters. We could reduce this just like you would a fraction, 8 over 6. We could divide, excuse me, we could divide 2 into each of those, and we could simplify that a little bit to make it 4 oxygens for every 3 waters. But the way I've got this one written, we could write it in 3 different ways: 1 to 8, 1 to 5, 1 to 6. So we're simply looking at the numbers in the balanced equation and balancing it out that way. All right. So number 2, got a lot of words, and one of the things I want to encourage you to do is, if you're working through these, is start trying to pay attention to where's the question, what numbers are we given, and so forth. So the question is here: how many grams of magnesium? Right. And the number that we're looking at is how many moles of magnesium oxide. So we're going from moles of one object to grams of another. That should tell us, when we're doing a conversion, where are we starting, where are we stopping. So if I draw out my conversion factors, notice I'm not starting with grams, so I don't have 4 sets of boxes here. I've only got 3 sets. So we're starting with moles. So we're going to go moles, moles, and grams, which means, again, on the bottom, the purpose of the bottom is to cancel out the top. We do that diagonally. One of the places I saw people struggle and make mistakes is not labeling things. So this is moles at the beginning of magnesium oxide, so it would be helpful if you would also write out MgO for each one of them. And then it's from mole to mole when we change substances and then go to magnesium. And magnesium would be our substance for the remainder. Okay. We've got 1.71 that goes at the beginning. This mole-mole fraction, that's how I need you thinking of it, is this is our molar ratio. So just like we did in question number 1, how many of each one do we have? So the number in front of the Mg is a 2. And for magnesium oxide, the number in front of it is also a 2. The last part, this is the molar mass, and the molar mass is always 1 mole. And I've already looked these up. So the number we get here for grams is the molar mass of magnesium, which is 24.31. So go through your calculator, start with 1.71. We can multiply it times 2. We could divide it by 2. You may have realized that those would just cancel each other out. And then we can multiply it by 24.31. Put all that together. Apparently, I did not work this one out already. So 1.71 times 24.31 gives me 41.5701. Still had a lot of people struggling with rounding. So that's what is in my calculator. The question says to round it to the nearest 0.01. So that simply means we want 2 places past the decimal. I don't need to change any number at all except possibly the very last one. And I'm going to look at its neighbor to the right and understand that that number is below 5, so I don't need to change anything. So my final answer needs to be 41.57. It also says round your answer. We also want our units. So this question is in grams, and it wants the substance, which was magnesium. So put that one all together like that. Okay. On number 3, again, kind of try to go through the same process of identifying where the question is, what information is given to you, and when able, go ahead and highlight, circle, underline. So you've got a certain amount of carbon. And then here's our question: how many moles of carbon dioxide? Marker's not working. How many moles of carbon dioxide will be produced? All right, so we're starting with grams of one substance. We're going to moles of the other one. So again, this is not going to be a 3-step problem. This is just going to be a 2-step problem. We're starting with grams, which means we need to change that to moles. And then we finish with moles of the other substance. So if we go grams, moles across the top, grams, moles on the bottom to cancel each other out diagonally. Again, I encourage you to write down the substances so you don't make an error with this. So I'm starting with carbon, 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 carbon. And it's not till we go from mole to mole do we change substances. And so this is where we would get our dioxide. All right, let's stick our numbers in. I got 52.78 at the beginning. I need to get the molar mass of carbon. So again, you're going to get that from your periodic table. 1 mole of carbon has a mass of 12.01. So again, going from the first step to the next step tells us how many moles we have. And then mole, we need to get that as our molar ratio because it tells us how many carbons, what the relationship is between the number of carbons and the number of carbon dioxides. There's 3 carbons for every 3 carbon dioxides. So we put a 3 and a 3 in there for each of those, which are going to cancel each other out. Again, we do our math. I've got the number I start with. I'm going to divide it by the number that's on the bottom. I can multiply it by the 3 on top and divide by the 3 on the bottom, but ultimately those are just going to cancel each other out. And I'm left with 52.78 divided by 12.01. Calculator gives me a really long number, so let's make sure we get it in correctly because it does want me to round to the nearest 0.01, include units and the substance. Calculator has a 4.39467 and then some other numbers there as well. So if I'm rounding to the nearest 0.01, I need to have that many digits in there, and I need to look at the first number that I'm not including to decide do I round or not. This number is below 5, which means I don't need to round. I don't need to do anything. So I'm going to do 4.39. That's what's going to should go in my answer. My units are, here's my question, how many moles? Which is also what we have here. My substance is carbon dioxide, CO2. So 4.39 moles of carbon dioxide. 2-step problem. All right, number 4. This is a conversion between molecules and moles. By definition, a mole is a counting number. And so, as we went over before we had our test, 1 mole is 6.02 times 10 to the 23rd atoms or molecules or whatever it is. Reminder that when you're putting it in the calculator, you would need to put 6.02, and you would need your calculator to have an E on it. So we hit the second button, and then we hit the button above the number 7. You don't want it to say times E You don't need it. There's no other symbol that needs to be in here. So 6.02 E 23rd is what you want your calculator to have. The relationship here is, again, this is what I'm starting with of how many molecules. So I have 1.74 times 10 to the 24th. And again, it's helpful to write things out, molecules. We're going to cancel out our molecules and turn the molecules into moles. So again, here's our relationship that goes into that fraction, because 1 mole is 6.02 times 10 to the 23rd. So in our calculator, we need to do 1.74 times 10 to the 24th. So again, my calculator, 1.74 E 24th divided by 6.02 E 23. I hit the equal button. I get 2.890. Right? I need 2 places past the decimals, so I need that many numbers. Because the first number that I'm cutting off is less than 5, I don't need to round, so I put this in as my quantity. Again, the units in this case are going to be moles, which is MOL. And the substance in this case was imaginary compound J, so it's going to be moles of J. And then finally, for now, on number 5, a lot of errors on this question in particular. So the question is about a limiting reactant. The limiting reactant is the thing in a chemical reaction that we're going to run out of first, and it's going to cause the reaction to stop. So in this case, if we have leaves burning, leaves are one of my reactants because it's a combustion reaction. One of the other reactants is oxygen. Fire is not a reactant. Smoke is not going to be a reactant. So the limiting reactant has to be one of the things that's causing the reaction to occur. So basically, we've either got leaves or oxygen right here. If the leaves are allowed to burn undisturbed, the first thing we're going to run out of isn't oxygen. The thing that we're eventually going to run out of is leaves. So in this case, the limiting reaction is the leaves, simply because that is the thing that is going to disappear on its first, and that's the thing that we're going to run out of first.